Hello everyone. My name is Ajit Chadaga. Welcome you all to the session on TensorFlow. So in this particular session, we would be unwrapping what exactly is TensorFlow and its functionalities. So let me share my screen now. So I hope my screen is visible. So what exactly is TensorFlow? So TensorFlow is an open source software library basically developed by Google in the year 2015. The main reason for Google to develop TensorFlow library is to help the developers to design, build, and implement machine learning and deep learning models. And later, it was being open source to help the community to make use of TensorFlow. So at a high level, TensorFlow is a Python library that allows user to express arbitrary computation as a graph of data flows. So when you say graph, there are two major components which are present in graph. So one is called as nodes and other is called as edges. So the node in the graph basically it represents mathematical operations such as addition, subtraction, division, whereas edges represent so the data that is communicated from one node to another node. So I would be explaining you with an example what does graph looks like in few seconds. So before going to graph, so let us see this particular diagram where TensorFlow is being split into tensor plus flow. So basically, tensor means it's basically a multi-dimensional array. So whereas flow is nothing but mathematical operations. So the data in the TensorFlow are represented as tensors. So that is what we would be able to understand that meaning of TensorFlow. Okay. So the next example, what I have given is how do we understand graph? So I've considered this following expression A equal to B plus C into C plus 2. So let us see how do we visualize this or understand this in a graphical way. Okay. So as you can see, the circles are basically, this is called as nodes. And the arrow mark, which is coming from one node to another node is called as edges. Okay. So before understand this graph, let us understand this expression what I have given. So A is equal to B plus C into C plus 2. So now in the next step, what I've done is basically this particular expression I've broken down into two separate variables. So the B plus C has been assigned to D and C plus 2 has been assigned to E. So in the next level, basically A is equal to D into E. So let us see how do we get this done in graphical way. So I have two input variables, B and C. So similar what I've used here for D equal to B plus C. So in the next stage, what it does is, so D is equal to B plus C has been achieved. So in this particular level, in a similar way, E is equal to C plus 2. So C plus 2 has been achieved in the second level. So in the third level, it combines the output of this and output of this basically in order to form A is equal to D into E. So this is how you represent these operations in a graphical way. So the next topic, what we'll be understanding is session. So in order to perform all these operations, you need a session to be established. So let us understand what exactly is session in TensorFlow. So I would be importing the library TensorFlow as TF. So import TensorFlow as TF. Okay. So now we would be creating a constant. Constant is an element which does not change. So we would be assigning it to a variable. So this is the syntax. How do we define a constant in the TensorFlow? It starts with tf.constant and the string what I've given is welcome. So when I give shift control plus enter and execute it, so usually in normal Python language, you would be seeing the output. Whereas in TensorFlow 1.x version, you would not be able to see the output because the TensorFlow object is being created. So this A is nothing but what you're seeing is a TensorFlow object. The output has not been seen. So how do we see the output basically? So as I told you in the graph, basically, in order to perform any operation, you need to create a session. Okay. Basically, the session provides you the resource in order to perform the operation. So in a similar way, we need to create a session here and run this particular operation here so that we would be seeing what A holds. Okay. So with tf.session as SCSS, and the next line O is equal to session.run A and print O. Basically, when we execute this particular statement, we would be able to see the output welcome. Okay, so this is how the session is being used. So session basically it provides resources in order to perform the operation. So let me take another example. where I've taken two variables a and b and created a constant tf dot constant 4 and tf dot constant 3. Okay, so in the session, basically, I would be doing an addition operation. So with tf dot session as yes, c is equal to s dot run a plus b and printing the c. When I print this, basically, I would be getting an output 7. Basically, 4 plus 3 is equal to 7. So let me change this particular value to 7. And now I execute it. So 7 plus 3 is 10. So basically, what all operations you're supposed to perform in TensorFlow 1.x, you need to create a session first and then feed these constant values or the what operation you're supposed to perform within this session. Okay. So basically, in TensorFlow, data is not stored in any of the data type formats such as integer, float, and string. All these values are basically encapsulated in an object called as tensor. So in tensor, basically, you have different dimensional tensors such as zero dimensional tensors, one dimensional tensor, two dimensional tensors. So let us understand how do we create those zero dimensional tensor, one dimensional tensor, and two dimensional tensor. So I have taken this particular example. A is equal to tf dot constant. So this particular zero dimensional tensor has already been defined here. So as you can see here, tf dot constant, the same way I've given integer here. So this is how you create a zero dimensional tensor. So the next example is b is equal to tf dot constant, and within the list you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how you create a one dimensional tensor. So basically you create it inside a list. Okay. So the next example is how do we create a two-dimensional tensor. So I've taken this particular example. So c is equal to tf dot constant. So basically a list in within a list. So you have two lists. So one is the inner list, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, and 222, 333, 444. And this has been wrapped with another list. So this is how you define a two-dimensional tensor. So the concept remains the same. If you know NumPy, TensorFlow has been built on top of NumPy. So majority of the operations, what you do here, so it would be same as NumPy, numerical Python, basically. Okay. So let me execute this. Okay. So now I've taken this particular example C. Okay. So I am able to see only the TensorFlow object being created. So in order to know what values are present in C, so I need to create a session. So how do we create a session? So I just told you a few seconds before with tf.session as s, k is equal to s dot run. And we are passing this particular value to this. So, and we'll be executing this. So as you can see the output 1, 2, 3, 4, 5, 6, 7, 8, 9, 222, 333, 4. So we can see the output in this session. So this is how we define a two-dimensional tensors. Okay. So So the next topic we would be seeing is placeholder. So just to give a recap, so right now we know what exactly is TensorFlow. So basically the graph concept in the TensorFlow, the nodes and edges, and later in order to perform any operation, we need to create a session. And we understood the concept of constant, and later we have understood the concept of how do we define a zero dimensional tensor 1 and 2. So the next topic is what is tf dot placeholder. So basically one difference between tf dot placeholder and tf dot constant is basically, so tf dot constant, the value is being passed before the runtime, whereas placeholder is basically used in order to provide the value to the session during the runtime. So let us see how do we execute it. So I have created a variable x is equal to tf dot placeholder, and within parenthesis, basically we have tf dot string. So basically in placeholder, we should not be giving any values. As I told you, placeholder basically accepts the value during the runtime. But during the runtime, before basically we provide the value. But before the runtime, we need to mention what data type it holds. So I have given tf dot string, which means during the runtime, it is supposed to hold a string value. Okay, so x is equal to tf dot placeholder. Let me execute this. Okay, and the similar way, we have opened a session, we have created a session, and within the session, session dot run, and I'm passing this particular variable x. Okay, and I'm feeding this dictionary. So x is holding basically a variable, sorry, a string called as Ajit. Okay, and I'm basically printing this. So when I print this, basically I'm able to get this. So what I'm doing is I'm passing this value during the runtime. So let me change this particular string during the runtime. So here I will be creating. So we are having a new variable Ajay. So we are having a new string. Okay. So this is how the placeholder works. So placeholders basically used in order to pass the value during the runtime. Okay. So let us see few more examples. Okay. So here, what I've taken is I've taken three variables, x, y, z, and to each variable I've assigned a placeholder. So x basically should hold a value tf dot string. Y is another placeholder which is supposed to hold only integer value, whereas z is another placeholder, it's supposed to store only float value. Okay, so this is the condition what I've given. So I would be creating a session with tf.session as SCSS, and output basically what I've given is I've this particular value is x, and I've feeded the dictionary x as test string. So x is basically I've given the condition into the placeholder that it should only accept string. Similarly, y is 1, 2, 3, where I've told y that it's supposed to hold only integer, and z is equal to 45.67. 40, it's a floating point number. So here I've mentioned z has to hold only floating point number, whereas output is what I've seen is only x value. Okay, so as you can see here, I'm only expecting x. X should be returned here. Okay, in the next line, output y. Similarly, what we have done in the previous line, we have done the same way, feeding the values to all the variables. But output, what I'm looking for is only y. So in the next line, what I would be doing is I would be printing these two variables. So print output x and output y. So when I print this particular statement, basically I'm only able to see x test string. So this particular output, and in the next line, output to y basically is 1, 2, 3. So this particular statement. So this particular statement is executing. So this is how the placeholder works. So basically, placeholder helps you to provide the value during the runtime. So I hope you were able to follow all like what all I've taught in this particular class. So in the next session, we will be understanding few mathematical operations. How do we do in TensorFlow, such as addition, subtraction, division, and how do we define a variable? Okay, and there's how do we implement probability functions such as softmax using TensorFlow. Okay, so hope you like this particular video. So thank you all. Bye.